All right. So once again, a very good morning to all of you. We are into exploring generative AI webinar, and we are super excited to deliver this particular webinar so that you can get acquainted with what exactly this field is all about. Gen AI, there is a lot of buzz in the industry these days. So we will be trying to touch base that what exactly this field is all about. All right. So a lot of content we will be covering in next 4 hours. All right, so let's get started. Now, people worry that computers will get too smart and take over the world. But the real problem is that they are too stupid and they have already taken over the world, right? And this is the reality. You just look around, you can see that computers have already taken over all the ecosystem around us, right? And in this context, we are super excited to talk about what exactly the Gen AI or in general AI is. All right. So, what is the agenda for today? What all we are going to cover? We are going to cover these things in the session today. We are going to talk about introduction to Gen AI and the AI landscape in general. Where does this Gen AI fits into the AI landscape? We are also going to talk about the machine learning and generative AI, how they are similar, dissimilar, related, unrelated with each other, right? We are also going to talk about generative AI and LLMs, large language models, because they are basically the major component of the generative AI area. We are also going to talk about the input output generative AI systems that commonly exist. We'll also see some of the examples of Gen AI technologies. We'll then see the SaaS via advantage, the SaaS platform advantage, and what is the SaaS's approach on generative AI. And then we'll touch base on the AI challenge, how we can balance the risk and the reward. And it's very important, right? It's not that AI or Gen AI is just only having the rosy side of it. There are challenges, and we would like to touch base those challenges as well in this session, right? So this is what the agenda is. So let's start with introduction to Gen AI and the AI landscape. Now, what exactly the generative AI is? Now, first of all, there are many different names or abbreviations that are generally being used. It is being called as generative artificial intelligence. It is called as generative AI. It is called as Gen AI. It is called as GAI, right? So there is no, I would say there is not a standard nomenclature or abbreviation that has been accepted in the industry, well accepted or universally accepted. There are many names of this particular technology. So what exactly all this generative AI is? Now, before getting into the generative AI, let's touch base quickly about some of the market trends. So generative AI technology has created a lot of excitement in the software industry and beyond as well. And shown here are some market trends, such as you can see Gartner places generative AI on the peak of inflated expectations. Deloitte anticipated that generative AI will change the future of work. McKinsey expects generative AI to unleash the next wave of productivity, and SaaS expands strategic partnership with Microsoft to deliver trustworthy generative AI value through industry solutions. So, what exactly the Gen AI is? Now, let's look at this incredible artwork created not by a human, but by AI. And in simple terms, generative AI learns from data. Generative AI refers to AI that generates content based on user input. It's like teaching a child to draw. Initially, the child observes and imitates, and over a period of time, the child start creating their own drawings. The pictures what you are seeing, these are AI generated pictures. These are, there is an annual event what SaaS conducts every year, SaaS Innovate. This is our largest user conference across the globe. And these are the pictures being generated based on some inputs, text inputs being given. So generative AI is a technology that can cause different reactions, I would say. Just think about the smartphone, which were launched in the year 2007. And some people were thinking, why would anyone want to have their photos in this thing? The point here is that no matter what we think about it, this technology is here to stay. So instead of avoiding generative AI, or I would say trying to control it, it's crucial to understand and embrace its potential and ask the right questions. For example, we should stop asking, will ChatGPT take my job? And instead ask, how can it make me more productive in my job? Or how is this going to change things? What does this mean for my job, my daily life, or my business for that matter? And what are going to be the new business models of the future? So, one thing is for sure that Gen AI technology is going to remain here. Now, obviously, generative AI is not just about art, it is much more. Generative AI technology includes large trained machine learning models that can generate some content. Typically, these systems work by accepting an input from a user, what we generally call it as a prompt, and generating some text or image or other data as an output for the user. So, generative AI is usually just referred to as Gen AI, and it is a subset of artificial intelligence, a type of AI. There are many definitions, excuse me, there are many definitions of Gen AI, but in the simplest terms possible, the definition of Gen AI is right there in its name. Gen AI generates new content, useful new content, and we say that it's generative AI. Now, as we said that Gen AI is the science, it's a subset of artificial intelligence or AI. And artificial intelligence is the science of designing ethical and transparent systems to support and accelerate human decisions and actions. This is how SAS defines AI or artificial intelligence. So, artificial intelligence is an exploding area within the field of, Gen AI is an exploding area within the field of artificial intelligence. And therefore, it is important to explore the AI backdrop and see where generative AI fits in. Now, AI is a branch of computer science that deals with the creation of intelligent agents, which are systems that can reason, learn, and act in an automated manner. Essentially, AI has to do with the theory and methods to build machines and think and act like humans. Advancements in computer processing and data storage made it possible to ingest and analyze more data than ever before. Around the same time, we started producing more and more data by connecting more devices and machines to the internet and streaming large amounts of data from those devices. All these advancements brought AI closer to its original goal of creating intelligent machines, which we are starting to see more and more in our everyday lives. From recommendations on our favorite retail sites to, I would say, auto generated photo tags on social media, many common online conveniences are powered by artificial intelligence AI. Now, most of these AI examples that you hear about today, from say chess playing computers to self driving cars, they rely heavily on machine learning, and machine learning gives the computer the ability to learn without explicit programming. Artificial intelligence is the broad science of mimicking human abilities, and machine learning is a specific subset of artificial intelligence that trains a machine how to learn. Machine learning automates analytical model building process. All right. Now, if you look at the early work in the field of machine learning, early work with neural networks actually stirred excitement for thinking machines. A neural network is a kind of machine learning inspired by the workings of human brain. It's a computing system made up of interconnected units, what we call them as the neurons, that process information by responding to external inputs, relying information between each unit. The process requires multiple passes at the data to find connections and derive meaning from undefined data. Machine learning and deep learning, you might have heard about deep learning as well these days a lot, right? So, machine learning and deep learning are subfields of artificial intelligence, and deep learning is a specific field of machine learning. Whereas machine learning mostly dealt with huge tabular data, what we generally call it as a structured data, rows and columns, right? Deep learning generally dealt with images, audio, and text as input data that results in even larger tables, because ultimately these image data, audio, and text data needs to be converted into a tabular information or the tabular data, right? But these are going to be enormously huge, right? Now, recent deep learning breakthroughs are actually driving an AI boom. Deep learning uses huge neural networks with many layers of processing units, which enable them to process more complex patterns that machine learning in large amounts of data, right? As compared to machine learning. Deep neural networks leverage artificial neurons, backpropagation, weights, and biases to identify patterns based on the inputs. So, having said that, machine learning and deep learning are both subfields of artificial intelligence, and deep learning is a subfield or a specific field within machine or a subfield within the machine learning. Now, when it comes to AI, artificial intelligence applies machine learning, deep learning, and other techniques to solve problems in areas such as computer vision, natural language processing, and Internet of Things, to name a few. Now, computer vision, which is abbreviated as CV, is a field of artificial intelligence that trains computers to interpret and understand the visual world. Using digital images from cameras and videos and deep learning models, of course, machines can accurately identify and classify the objects and then react to what they see. When machines can process, analyze, and understand images, they can capture images or videos in real time and interpret their surroundings. From recognizing faces to processing the live action game of a football game, computer vision rivals and surpasses human visual abilities in many, many areas. One of the most simplest example of computer vision is the face recognition in our mobile phone, for example.
When a computer looks at an image, it sees pixels, and each of those pixels have a specific value. So when I look at something in my sight, I see different colors. Well, a computer doesn't see the colors specifically, it sees numeric values that back those colors. And then it can use all of those numbers and do lots of fancy calculations behind the scenes to reason about what might be happening in that image.
A quick check, were you able to listen to the audio. Thank you so much for confirmation. Another application of AI is the natural language processing, what we generally abbreviate it as NLP, right? Natural language processing. Now, NLP is also a branch of artificial intelligence that helps computers understand, interpret, and manipulate and generate human language, including speech. NLP helps computers communicate with humans in their own language, making it possible for computers to read text, hear speech, interpret it, measure the sentiment, and determine which parts are important in a free flow text. The next stage of NLP is natural language interaction, NLI, which enables humans to communicate with computers using normal, everyday language to perform tasks.
Unstructured text is the largest human-generated data source, and it grows exponentially every single day. And people are accessing information and interacting with smart devices through conversation. With growing volumes of social media posts, emails, electronic record systems, and digital chat options, how can you make sense of the noise and actually hear what people are saying? Natural language processing is a branch of artificial intelligence that does just that. It structures and interprets human language in ways that allow a computer to automatically identify themes in conversation, reveal correlations across massive databases, and provide a bridge to help humans find the information they need when they need it. People are talking. Are you listening?
And one more application area, common application area of AI is the Internet of Things, abbreviated as IoT, right? Now, IoT refers to a vast number of things that are connected to the internet so that they can share data with other things. Now, things here could be any devices. IoT applications include, say, connected devices, industrial machines, and more, right? Internet connected devices use built-in sensors to collect data and in some cases act on that data. IoT connected devices and machines can improve how we work and live. Real world Internet of Things examples range from a smart home that automatically adjusts heating and lighting to a smart factory that monitors industrial machines to look for problems and then automatically adjusts to avoid failures. The Internet of Things generates massive amounts of data from connected devices, and most of it remains unanalyzed. Automating models with AI will enable us to use more of that kind of data. Now, these are some of the common uses of AI, what we have seen.
More than ever, organizations are focusing on creating the next ideal interaction with their customers. The customer experience is data-driven, and the Internet of Things allows expansion and enhancement of the customer journey. IoT combined with machine learning is transforming into the artificial intelligence of things. AIoT empowers companies to gain meaningful insights and improve customer experience. Here are 3 examples of how AIoT adds value to your CX journey. Rhonda's retail store employs AIoT by connecting her shoppers' digital life through their smartphones to their physical location and offering real-time in-store promotions and discounts. Alonzo uses AIoT to create a new automotive service for his company's IoT-equipped vehicles. Now he can predict maintenance needs and conveniently schedule appointments while providing consistent customer service. Tina works in telecommunications and utilizes IoT data as a foundation for her CX strategy. She monitors her network, relays current and predicted usage to customers, and allocates resources appropriately. Innovative companies are using AI and customer-generated IoT data to improve the customer experience. AIoT enables companies to go beyond traditional customer experience to become embedded in their customers' world. Find out how to ignite your customer experience and improve your CX strategy with SaaS.
Now, in addition to these applications, what we have seen, there are several technologies that enable and support AI, right? For example, graphical processing units or GPUs, they are key to AI because they provide the heavy compute power that is required for iterative processing. Training neural networks requires big data plus computing power, right? Similarly, advanced algorithms are being developed and combined in new ways to analyze more data faster and at multiple levels, I would say. This intelligent processing is key to identifying and predicting rare events, understanding complex systems, and optimizing unique scenarios. Application programming interfaces, what we call them as APIs, these are portable packages of code that make it possible to add AI functionality to existing products and software packages. They can add image recognition capabilities to home security systems and Q&A capabilities that describe data, create captions and headlines, or call out interesting patterns and insights in data. APIs play an important role in facilitating connections between input and some logic, what we call it as AI, and subsequently connecting that logic with the output. Thus, APIs make it easier to interact with AI system by accepting input parameters and providing consumable output. So in summary, the goal of AI is to provide software that can reason on input and explain on output. AI will provide human-like interactions with software and offer decision support for specific tasks, but it's not a replacement for humans, and it won't be anytime soon. All right. So this is what the AI in general we talked about, and here's a poll for you. Which of the following is an example of computer vision? And let me launch this poll for you so that we can have some amount of interactivity here. Oh, I don't think that I can. Dave, is there any chance that I can add some polls here?
Yes, sir. Just try to click on plus icon. When you click on polls and quizzes, just click on plus icon.
I clicked onto the polls and it is showing me the polls what you have created here.
Okay. So
If we can't, then that's absolutely fine. We can just use the chat window.
yeah, I think we have to make it.
And sorry that I didn't tell you in advance that we have to calibrate it.
We can use the chat option also.
All right, so great, friends. Can you just use the chat window in order to just type in the option here? Which of the following is an example of computer vision? All right, thanks for your responses. Yes, the correct answer here is the facial recognition based security access in your phone is an example of computer vision. Thank you so much for your responses. So now we finally get to where generative AI fits into this AI landscape. Generative AI is a specific field of artificial intelligence that uses several techniques that continue to evolve. Foremost are deep learning algorithms such as convolutional neural networks (CNNs) and recurrent neural networks (RNN), which consist of multiple layers of interconnected nodes that accept large quantities of data as inputs and identify patterns or structures within the dataset. CNN is mostly being used for image recognition and computer vision tasks. It works by pulling important features that from an input image. On the other hand, RNN is used in advanced fields like natural language processing, handwriting recognition, time series analysis, or forecasting, and so on. Generative AI can process both labeled and unlabeled data using many machine learning algorithms like neural network, K nearest neighbor, and more. Generative AI also uses some of the reinforcement learning algorithms that focuses on sequential decision making problems. We will be touching base at a very high level what exactly the reinforcement learning in the some of the later part of the session. The goal of a reinforcement learning problem of such algorithm is to train an agent to perform actions in order to optimize an objective based on a reward signal. On top of all these things, a recent breakthrough of transformer model has revolutionized how we use machine learning to analyze unstructured data. NLP transformers I'm talking about. And the transformer in NLP is an innovative architecture that aims to solve sequence to sequence tasks while handling long range dependencies with much ease. One of the key innovations in transformer models is the use of the self attention mechanism, which enables the model to weigh the importance of different parts of the input and output without using sequence aligned RNNs or CNNs. Transformers are used to train a class of models called as large language models, LLMs. Large language models are also a subset of deep learning. So having said all these things, Gen AI is a specific field within deep learning, within machine learning, or you can say Gen AI is a subset of artificial intelligence. The breakthrough comes with the innovation of the transformer models. Not only these, you know, there are other things also. And if you broadly speak, whereas traditional AI ML systems recognize patterns and make predictions, GAI systems, generative artificial intelligence, GAI systems learn real world data to generate data like text, images, audio, tabular data, simulated data, code, and so on, with similar probabilistic distributions and characteristics of the real data. Now, simply put, you can get more work done using Gen AI stuff. You can produce a large volume of output that that subsequently drives organizational key performance indicators and overall business value. Synthetic data generation is currently available as one of the very common applications of Gen AI technology. Not only these algorithms which are driving, there are other algorithms also that includes uh, variational autoencoders and generative adversarial networks. So if I put the Gen AI components, in addition to these, there are few more like variational autoencoders and GANs. Now, variational autoencoders are a type of generative model that learn to encode input data into a probabilistic latent space and then decode samples from this space back into the original data format. They use a combination of neural networks and variational inference to generate new data like the input distribution. On the other hand, generative adversarial networks, GANs, consist of two neural networks, a generator and a discriminator, that are trained together. The generator creates fake data while the discriminator tries to distinguish between real and fake data with the goal of improving the generator's ability to produce realistic outputs. So when it comes to look at the Gen AI components, these are the common components, and the most important ones are the NLP transformers are the game changer, introduced way back in the year 2018, right? Now 6 years time in AI field is been called as way back, right? And that's why I did use, because this field is changing so fast, the technology is improving and changing so fast almost every day, right? And variational autoencoder and GANs, these are the major components of the Gen AI, generative AI. So here we come to the end of the previous section, and let's get into the next section, how machine learning and generative AI are related, unrelated, dependent, not dependent, similar, dissimilar with each other, right? So basically, I would put it, machine learning and generative AI, they are going to complement each other. So machine learning is the most critical constituent in AI, right? So how does machine learning work? There are many different methods of machine learning. What they all have in common is that they are automated and adaptive. Machine learning techniques are sometimes modeled after the human brain. I would like to use a simple example of distinguishing an apple from an orange. If I want to make an apple pie and I ask you to bring home apples from the market, you need to be able to tell an apple from an orange, right? If you come home with oranges, well, best case scenario, there will be no dessert for you. Luckily, you can do this easily because over time, as a child, you learn to differentiate an apple from an orange based on color, size, smell, and texture. Someone would tell you that yes, that is an apple, or no, that is not an apple. This is called supervised learning. Color, size, smell, and texture are all features or attributes, or as statisticians like to call them, say they are independent variables. These features help determine the outcome. In this case, the outcome is binary. It's an apple or it's not an apple. In your brain, these different attributes are weighted differently. For example, texture and color might be weighted higher than size because it is better at differentiating apple from oranges. And likewise, with a higher level of training, I can distinguish a Granny Smith apple from a Fuji apple, right? And given more inputs like softness, water content, and ethylene gas emitted, I could determine not only if an apple is rotten, how likely it is to become rotten even before it has become brown and squishy. So, depending on the nature of the business problem being addressed and the type and volume of data, there are different approaches to machine learning. Deep learning models or machine learning models in general can be divided into three types: discriminative, reinforcement, and generative. Generative AI is this third type, what we would like to discuss, although we will be discussing all of them. But generative AI is just a type of machine learning. So let's start with discriminative model first. What is a discriminative model? A discriminative model classifies or differentiates between dissimilar kinds of data instances. Thus, it can be used to predict the labels or values of new data points. Unlike discriminative model, reinforcement learning, there is no classifier. Instead, there is a reward signal that serves as the feedback mechanism. A reinforcement learning model maximizes a long-term reward accumulated over a sequence of actions. And this occurs as an iterative process through trial and error method. On the other hand, a generative model generates new data instances based on a learned probability distribution of existing data. Thus, generative models generate new content. Now, discriminative models, when it comes to the discriminative models are task driven. Therefore, they can be further classified into supervised learning, unsupervised learning, semi-supervised learning. Let us briefly discuss each of these types of machine learning. What is supervised, unsupervised, and semi-supervised? When it comes to the supervised learning algorithms are trained using labeled examples, such as an input where the desired target is known. So here you have the target variable known. Suppose the individual is a defaulter or a non-defaulter. And then you have several input variables like age, income, education, qualification, and so on and so forth. So here the value of the target is used as the label for an observation in the table. And the learning algorithm receives a set of inputs along with the corresponding correct targets. So targets are known here. Labels are known here. The target variable could either be categorical or continuous, and the algorithm learns by comparing its actual target with the predicted target to find errors. It then modifies the model accordingly and produces a classifier. In this example, here you have a binary target, navy blue squares and light blue circles. And a linear classifier is represented here with a teal line that differentiates navy squares from light blue circles, right? So this is a classifier which is differentiating between these two types. Supervised learning is commonly used in applications where historical data predict likely future events. For example, supervised learning can anticipate when credit card transactions are likely to be fraudulent or which insurance customer is likely to file a claim or a loss reserve, which is an estimate of an insurer's ability from future claims that it will have to pay out on. The second type is the unsupervised learning, and unsupervised learning is used against data that have no historical labels. You do not have a target variable here. You'll just have a set of input variables available. The system is not told the right answer. The algorithm must figure out what is being shown. And here the goal is to explore the data and find some structure within it. Unsupervised learning commonly attempts to group training data set cases based on similarities in the input variables. It is a data reduction method because an entire training data set can be represented by a small number of groupings or clusters or segments. These groupings are known as clusters or segments, as I said, and they can be applied to other data set to classify the new cases. For example, here you have all the observations represented by gray triangles because no labels are available. A cluster structure is represented here with teal ellipses that group the gray triangles into two mutually exclusive clusters. Broadly speaking, unsupervised learning is a feature engineering method that can represent data in different dimensionality. It could be reduced or even expanded. Feature engineering is a task within some generative models as well. For example, embeddings and transformers within the large language models. So unsupervised learning works well on the transactional data. For example, it can identify segments of customers with similar attributes who can then be treated similarly in marketing campaigns. Popular techniques include self-organizing maps, nearest neighbor mapping, k-means clustering, singular value decomposition, and many more. These algorithms are used to segment text topics, recommend items, and identifying the data outliers as well. So these are basically the pattern matching or pattern detecting tool, unsupervised learning. And then you have a semi-supervised learning. Now, semi-supervised learning is used for same applications as supervised learning. It uses both labeled and unlabeled data for the training. Typically, a small amount of labeled data with a large amount of unlabeled data because unlabeled data are less expensive to acquire and take less efforts. It's kind of a marriage between, I would say, supervised and unsupervised learning. And this type of learning can be used with methods such as classification, regression, and prediction. Input variables are used for distance calculation here. For example, here you have a binary target, navy blue squares, and light blue circles available for a number of observations that, and most of the other observations represented by gray triangles as no labels are available. Now, based on the labeled data, a nonlinear classifier is represented here with a gray curve that differentiates navy blue squares with light blue circles, right? A cluster structure is then represented here with teal ellipses that group the gray triangles into two mutually exclusive groups or clusters. Points on the same structure are likely to have the same label, and this assumption is often called as the cluster assumption. This is what semi-supervised learning do. So some of the you know useful cases of semi-supervised learning includes So it has numerous applications, including web page classification, image recognition, medical imaging, and natural language processing, action recognition, and many more. Semi-supervised learning is useful when the cost associated with labeling is too high to allow for a fully labeled training process. All right. Let's come to the second type of machine learning, what we call it as a reinforcement learning. Now, reinforcement learning methods rely on a reward signal to train a policy. It has three primary components: the agent, the what we call it as a learner or a decision maker, the environment, everything the agent interacts with, and actions, what the agent can do. And here the objective is for the agent to choose actions that maximize the expected reward over a given amount of time. The agent will reach the goal much faster by following a good policy. So the goal in reinforcement learning is to learn the best policy. What could be an example of a reinforcement learning? Reinforcement learning can probably be best explained through an analogy to a video game. As players progress through the virtual space of a game, they learn the value of various actions under different conditions and become more familiar with the field of play. Those learned values then inform the player and influence the player's subsequent behavior, and their performance immediately improves based on their learning and experience, right? What are the common application? Reinforcement learning is often used for robotics, gaming, and navigation, like a self-driven car. With reinforcement learning, the algorithm discovers through trial and error which actions yield the greatest rewards. Thus, it is mainly used for sequential decision-making problem, right? Another example could be self-driving car. The car exists in an environment that includes roads and so on. Actions the car may take could include, say, moving forward, stopping, turning right, turning left, and so on, right? And the goal may be for the self-driving car to take me from my house to my favorite restaurant in the quickest way possible, following all rules of the road and all safety precautions, right? So this is a good example of reinforcement learning. So reinforcement learning, keep learning using trial and error, and it's a sequential process. In every, over a period of time, it keeps improving the environment learning and then takes the best actions or the rewards, maximizing the rewards. So again, a question for you: which of the following is true regarding machine learning approaches? You can use the Q&A section to answer, to just type in your response. All right, thanks for your responses. The correct answer is B. Supervised learning predicts the output based on inputs target association. I can see that the responses were for against A, C, and D as well, but those are the incorrect ones. A is incorrect. Unsupervised learning discovers underlying patterns based on input target association. No, unsupervised is just going to learn the patterns using only the input similarities. There is no target variable. So A is a wrong answer. C, the input data in supervised learning is unlabeled. The input data in supervised learning is labeled. That's why C is wrong. And reinforcement learning follows a proven method, and the data is predefined. The data is not predefined, and there is no proven method. It's a trial and error method, right? And it keep learning, improvising every time. All right, so here we come to the third type of machine learning, what we call it as generative models or the AI. And recall that generative AI systems learn real world data to generate seemingly new content, such as text, images, audio, video, tabular data, synthetic data, and code, with similar probabilistic distributions and characteristics of the real world data. Generative AI can produce highly realistic and complex content that mimics human creativity, making it a valuable tool for many industries such as art, writing, software development, product designing, healthcare, finance, marketing, fashion, and many more, right? So, in order to look at the generative model, what exactly a generative model is? A generative model generates new data instances based on a learned probabilistic distribution of the existing data. And as a result, generative models generate new content. Let's consider an example of image processing. Image generation refers to the creation of synthetic images using AI algorithms, primarily employing techniques such as generative adversarial networks and stable diffusion models. Suppose you have images of mountains in your sample. The generative model learns the joint probability distribution or the input output probability and predicts the conditional probability that this is an image of mountains, and can then generate high quality pictures of mountains that are both unique and visually appealing. With image to image AI, you can take any input image and transform it into a completely different style while still retaining certain similarities to the original image, right? So you have images of mountains and you are generating new mountain images based on those input images. This is a kind of a generative model. Now, how are generative models different from discriminative models and reinforcement learning then? So let's continue with the example of image processing. You have images of mountains and plains in your sample. The discriminative model learns the conditional probability distribution or the probability of outcome given the inputs, that this is a picture of mountains, and classifies it as mountains and not plains. Thus, to summarize, generative models can generate new data instances, whereas discriminative models discriminate between different kind of data instances. In this case, whether this is an image of a mountain or whether this is an image of a plain. Let's extend the image processing example to reinforcement learning as well, right? Mobile robots, you might have heard about the mobile robots many a times. Now, mobile robots equipped with visual sensors learn their surrounding environment by applying frame by frame image processing for navigation. A robot moving on mountains will be way different than moving in plains. Mobile robots must navigate in an unknown environment without colliding with static and dynamic obstacles to perform a certain task in the environment. So generative, reinforcement learning is basically uh, learning the surroundings for the navigation, looking at the or using the images of plains and mountains. So this is an example of a reinforcement learning. Now, it's very important what I'm telling you now. Generative models can complement other types of machine learning. For example, the output of generative models, in this case, the output is the images, right? So, output of generative models, that is the new mountain images in this example, can be used as additional inputs in discriminative models and reinforcement learning. So, generative AI is something which complements the traditional AI, and they generally use these things or the output from one another. Having said this, AI systems can be used to do different things for us, such as forecast the demand for a product or the weather, recommend customized product suggestions for e-commerce sites, identify objects from images and videos, detect fraudulent bank transactions, or optimize large scale production systems. These are all examples of AI. On the other hand, generative AI is a type of AI whose job is simply to generate content, whether it is text, images, audio, video, code, table, whatever. That is what the generative AI is designed to do. Now, one more important thing here, you know, at times people just try to differentiate that yes, a standalone, exclusive, this is Gen AI and this is AI. And in most of the practical situations, we might not be able to do this exclusive distinguishing between AI and Gen AI. A generative AI application need not consist of generative models alone. For example, let's consider the insurance loss reserving example. A discriminative model could be used to predict required reserves. A reinforcement learning model could be used to assess different scenarios and optimize. And finally, generative models could be used to simulate data or advise on actions to take. So in this example, you can't say that this is exclusively a Gen AI application. This is a mix of all types of AI which are generally being used, and that is what the reality is, right? They just use the things from of their from one another. So, what is your first takeaway? The first takeaway you want to take home today is that with generative AI, we are witnessing a transformation of the interaction between human intelligence and artificial intelligence. Gen AI makes AI easier for all of us to interact with. It is not just for tech savvy individuals, it democratizes the access to AI for both technical and non technical audiences. All right. Let me just see whether if I am having any questions here. There's a question: unsupervised learning uses unlabeled data and discovers patterns through common features. That's absolutely right. Unsupervised learning discovers targeted associations. I do not understand the terminology here. Targeted associations means what? I think I do not have more questions here. All right. Thank you so much, friends. The next section is all about generative AI and LLMs. You might have heard about large language models, right? So let's discuss them in the context of Gen AI. Now, in this section, we will provide some insight into large language models. Large language models called LLMs are one of the most widely used algorithms in the generative AI space. We all know that. And we will briefly walk through an example of interacting with a large language model and then review some of the most common LLM providers. Finally, it's important to be aware of a few risks and challenges related to this exciting but rapidly evolving space as well. All right. So, what exactly the large language model does? Large language models learn, LLMs learn about patterns in language through training data, right? They, given some sort of text, they predict what comes next. So, they actually look at the relationships in the language. They are essentially the pattern matching systems. Yeah, I do have some raised hands here. So let me take up those, please. Would you like to ask anything here? Nunam, Ron, Clady, if I'm pronouncing your names correctly. Your hands are raised. Would you like to ask something? Okay, whenever you feel so asking, just do let me know. So we were talking about that what large language model does, they just ascertain the relationships in the language, and they are essentially the pattern matching systems. For example, one of the simplest example could be, say, in Rome, suppose if this is the text string, in Rome, I am visiting Colosseum, and then the large language model is going to look at what can be filled here, the next word here, and it could be a, say, I'm in Rome, I'm visiting Colosseum and what, Vatican City, St. Peter's Basilica, Rome Pantheon, Rome Forum, and so on and so forth, right? So there could be many different possibilities, and what is going to be the best matching here, that is going to be predicted, or that is going to be uh, ascertained by the large language model, right? By the way, Rome is beautiful. Similarly, this is another example from Google Gemini, formerly known as Bard. And here are some things to do near the Colosseum. The same question is being asked here. In Rome, I am visiting Colosseum and what? And it has given me different, uh, you know, recommendations here. Roman Forum, Ark of Constantine, and so forth. And their description, a brief description has also been given along, along with them. Not only this, since it's Google and they have other applications, they have also given me their the names of these monuments, or they have been mapped these monuments onto the Google Maps so that you would be able to see how close they are and far from each other. All right. So having said this, the power of LLMs come from the use of transformers. You know, the in the year 2018, the real breakthrough comes in the form of the NLP transformers. And transformers produced a 2018 revolution in natural language processing NLP field. So what exactly the transformers are? The transformer architecture is based on the concept of attention, which allows the model to focus on important parts of the input sequence. When I'm saying input sequence, I'm talking about the input text, right? So it is based on the concept of attention, and it focuses on the important parts of the input sequence while ignoring the irrelevant information. So the words or the terms which are more important, those are going to be given a higher weight, and the less important or irrelevant words or information is given a lower score for them, relevance score for them. And this attention mechanism is used to compute weighted sum of the input sequence, which are then used to compute the output sequence. So the input sequence is being weighted, and based on those weights, the output sequence is going to be given to you. So in Rome, I am visiting Colosseum and Vatican City. Now, why Vatican City? Because Vatican City had given me a higher weight than others. And that's why the next word which has been predicted by the LLM, or which has been given by the LLM, is the Vatican City instead of others. Now, why were they called transformers? Well, because they transforms the input sequence into an output sequence using a series of transformer blocks. And each transformer block includes a self-attention mechanism and feed-forward layers of several neural networks which transform the input sequence at each layer of the model. All right. Let's look at an example. Suppose if I'm giving a prompt, when Pune was renamed to Pune, this is the city which I belongs to, which I am based out of. Now the current name of the city is Pune, Pune. It used to be called as Pune earlier. So I did ask the chat GPT, for example, when Pune was renamed to Pune, right? And in this example, you can see the input is this sequence of words, which is there in the form of a prompt. This goes into the transformer model. The transformer model has two parts, encoder and decoder. So when Pune was renamed to Pune, this goes as an input into the encoder. Then this is going to decode what is there. Then there is a generative pre-trained transformer models exist, and this model is based on large amount of data, billions of parameters into it, and this is an example of an unsupervised learning. And based on that, it has given me an output, and it has given me an output like this. The name change from Pune to Pune occurred in the year 1977. The city officially became known as Pune when the Indian government this, blah, 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 and so on. So the input goes into the transformer model. Transformer has two parts, encoder and decoder. And then that is going to be passed through a pre-trained generative model, wherein the billions of parameters have already been trained, and then it is going to produce the output. Right? You must have heard about chat GPT. A lot of people use the term interchangeably, assuming that generative AI is chat GPT. And the reality is that ChatGPT is a form of generative AI and is called large language model. Large because it has hundreds of billions of information that learns from. And language because it is capable of processing and understanding human natural language. This is how ChatGPT is able to write an article based on a prompt. So, what do LLMs do? How do they work? As mentioned earlier, generative AI is a subset of AI, and large language models are a subset of generative AI. LLMs are specifically focused on generating and understanding human language. What you see here is a simple example of ChatGPT. It is trained on vast amounts of text data, and can perform a wide range of language tasks such as answering questions, writing essays, translating languages, and so forth. You interact with the LLM by typing a question or a query. The query is referred to as prompt. The LLM, the chat GPT in this example, responds with human-like text based on that prompt. This is important. It responds based on the prompt and answers exactly what you asked for. Better or worse, think of this in very literal terms. In this case, imagine I'm thinking about getting a dog, but I'm not really sure what breed. I have heard of Kelpies and they are adorable, but I don't really know much about them. So I decide to get some more information, do some research. I ask ChatGPT, what is a Kelpie? And the answer is not quite what I expect. The first portion is talking about a mythical creature, somewhat dangerous creature by the sounds of it. Why is it telling me like this? It is telling me this because even though I was thinking about a dog, I didn't tell ChatGPT that. I didn't provide enough context regarding what I really wanted to know. The specific language you use in the prompt can deeply influence the output you receive, right? So what I did, I rephrase. When I rephrase the prompt to be a bit more specific, instead of asking what is the Calpy, I did ask what is the Calpy breed. I am rewarded with a more useful answer. I understand this is a very basic example, but the goal here is to illustrate the importance of constructing a meaningful prompt that returns useful results. The process of fine-tuning a prompt to get accurate, useful content is referred to as prompt engineering. We have explored what LLMs do and how do they work. Look at an example here. I did ask ChatGPT, what is 1, 2, 3, 4, 5, 6, 7, 8, 9 times 1, 2, 3, 4? I just asked the multiplication of the two numbers here. One is very big. And the answer is what has been shown in the screenshot here. Whereas the correct answer is way different. So ChatGPT won't ask for clarification and it won't admit what it doesn't know something. It is just confidently responds with an answer. And you could be in trouble if you don't check the answer. Now this is expected because ChatGPT is not a analytical tool. It is not being used. It's not a calculator at all, right? It is a language model. So it was not meant for doing these complex calculations. Says say some months down the line, some years down the line, it might have that feature as well, some analytical prowess as well, or some calculating prowess as well. But as of now, it is not being used for the multiplication of two complex numbers. So do not expect that you know this is a kind of a magic is going to be done for you for every question. Every AI system or every Gen AI system is being meant for doing a specific job or for some specific jobs. Not that it is going to, you can ask, you come up with any kind of question and then it is going to answer the questions correctly to you, right? So keep this thing in mind. It is not going to give you all the answers, and there is a tendency, and it's a human psychology, and there's a human tendency that if you're asking something to the machine and then if something is coming out of the machine as an output, we start believing that this is true. So be careful. Be careful whenever you are dealing with any kind of outputs generated out of the Gen AI system. Not only ChatGPT, but for that matter, any kind of Gen AI system for that matter. First of all, please be wary, please be aware about what it is being actually meant for, and then also look at its limitations, right? So these things are being called as hallucinations, right? You can use generative AI for creating content and graphics, writing code, building mobile apps, and solving problems, certainly. Now, while generative AI can be fun and useful to be used, we need humans to spot and correct wrong answers, and these are called as hallucinations. Now, hallucinations are kind of being a child, when from our childhood, we generally used to see the clouds, and then we start thinking that, okay, I'm seeing some old lady in these cloud images or something else, or a rabbit or something like that. So, have you ever seen figures in the clouds or faces on the moon? Of course, yes. And those are called as hallucinations. So, hallucinations are actually the words or phrases that are generated by the model that are often nonsensical or grammatically incorrect and easy to misinterpret. And for that matter, all Gen AI systems are prone, less or more for the hallucinations. So please be wary about this particular thing, that hallucinations are indispensable part of Gen AI systems. All right. You can now, as far as the chat GPT is concerned, day by day, all the Gen AI systems are improving. They are coming up with more and more capabilities. For example, you can now upload an image and have chat GPT give you an answer based on an image. For example, you need to fix something with your bike. You can go to the bike manufacturer's website, upload a picture of the bike, your toolbox, and the user manual. And ChatGPT can tell you how to solve the problem. This is how Gen AI can be like a collaborative partner and just one way to use this technology in your personal life. Not only this example, here are other ways that ChatGPT can be used in your personal life. It can help with interior design. Just upload an image of your living room, for example, then ask ChatGPT to describe the style and suggest a shopping list for you. You can use an advanced version of GPT-4 when you need to make dinner. You share all the ingredients you have in your refrigerator, and then the AI model suggests a recipe you can make. Or if you want to improve your website, you can submit an image of the homepage and ask ChatGPT how it could be improved, right? So ChatGPT, which is from the company OpenAI, is the most famous large language model, but it is not the only one, right? And we were talking about the hallucinations, and we are going to talk about some more, large language model providers. But I would like you to hear this conversation of two of my colleagues here. This is regarding using the chat GPT, or for that matter, any AI, Gen AI system. So use it with caution.
One more question for you. For the casual chat GPT generative AI user, what are some things that they should watch out for? Just general, pro tips, best practices that we should keep in mind.
I think my favorite, because like I said, we're all engaging with ChatGPT. There are people that are using it to generate a tremendous amount of content. Be careful. There is risk. The models do generate really excellent sounding results, and sometimes they're not really that trustworthy. My favorite example recently, I asked ChatGPT about text to speech synthesis, which is an area that I find interesting, which is essentially having a machine speak like a human. So you have to think about things like inflection and tone and the rise and fall of the voice depending on what you're talking about. So I thought it'd be interesting to see what it came back with. And it gave me a really nice explanation. I asked it to cite its sources, and it came back with 4 papers, and they all sounded believable. And it gave me links to the papers, which I thought, oh, that's really cool. So I click on the links, I get 404 not found errors. So the links are bad. So I thought, okay, well, I'm just going to search for the papers. The papers don't actually exist. So they sound plausible, but they're not real papers. They were not published works. So I asked ChatGPT, where can I find this type of information on the ACL anthology, which is a really big repository of papers around computational linguistics and natural language processing. So it gave me the same paper names with ACL anthology links. When I clicked on those links, it returned papers, but they weren't the papers that were cited because those papers didn't exist. So I took it one step further. Last step, I asked it for the authors of these invented papers, and it gave me authors that publish in the space, but the combinations of researchers didn't match up. And they certainly didn't write those papers because those papers don't exist. So if I had taken that information at face value, it probably wouldn't have panned out very well because none of it was real. It sounded plausible though, and the titles seemed very believable. The authors that were generated are real, but not in the right combinations. So my advice is use it with caution. So always check, always verify the work. I work with students, and I tell them that in general, if you're going to use generative AI to do your homework, your grade is probably going to reflect the level of effort you put into it. So use it with caution.
So this was a fantastic example of, whenever you are going to use any Gen AI system, it was not pointed or targeted to any specific one, but this is in general that, if you are using any Gen AI system, use it with caution because hallucinations are an indispensable part of all these Gen AI systems. So what are some of now to build on our understanding of large language models, let's explore some of the challenges and the limitations that are emerging in terms of accuracy, security, and governance. Now, there are several critical points regarding accuracy. This technology is evolving super fast, but as of now, we need to consider that despite their sophistication, LLMs can generate outputs that are factually incorrect, out of context, and even sometimes nonsensical. These erroneous outputs are called hallucinations. LLMs are also trained on data available up to a certain date, the knowledge cutoff date, what we call it as, and this limits their knowledge to that time frame. In addition, we talked about the effects of prompt engineering. The results you receive rely heavily on the context provided in the prompt. There was a well-publicized story about New York lawyers who were sanctioned for citing fake legal cases in a brief they generated using ChatGPT. You don't want to find yourself in that situation, of course. LLMs are also vulnerable to privacy and security risks. This brings us back again to the prompt engine. Remember, the prompt drives the output. While prompts can be maliciously manipulated to exploit the model, and then the LLMs runs the risk of revealing private information, disseminating false information, or even executing unauthorized activity. The UK's National Cybersecurity Centre has issued warnings about the risk of these so-called prompt injection attacks. And as it almost always the case, governance and control being a challenge. The way LLMs are deployed and used, it's going to vary widely across the providers. That raises questions about standardization and governance. With respect to control, LLMs are incredibly expensive to run. It's imperative to control workloads and minimize the waste. Commercial LLMs providers may change use policies or model behaviors, which can have a huge impact for both users and applications. Again, this requires ongoing monitoring, vendors, updates, and model outputs to reduce disruptions and ensure production systems perform as expected. For additional insight on governance and control, you can refer McKinsey's article on total cost of ownership, which provides an explanation of the financial impacts. There is also a link to the story about changes in OpenAI's use policy that demonstrates the dynamic nature of commercial LLM governance. As we delve into the realms of LLMs, understanding the nuances of accuracy, privacy, and security and governance becomes crucial for responsible use. Recognizing these challenges enables us to navigate the evolving landscape of LLMs more effectively, ensuring we leverage these powerful tools in a way that maximizes benefits while mitigating the risks. So there are risks. There is actually a proliferation of LLMs in the market. Now let's look at some of the most popular LLM providers. The biggest large language model today is the latest version of GPT called GPT-4. It has an undisclosed number of parameters more than 500 billion or even more. There are commercial providers and open source providers. Commercial LLMs are developed by private companies and require a subscription or a purchase. They are maintained by the company, updated by the company, and accessible through APIs or vendor provider GUIs. ChatGPT, Claude AI, Google Gemini, which was formerly known as Bard, are examples of commercial LLMs. Open source, on the other hand, are freely available for use, improvement, and modification by the global community. Having said this, specialized skills are needed to manage, build, and productionize LLM-powered use cases. Qwen, Mistral, and Microsoft Phi land, they land squarely on the open source side. Llama 2 is a very popular LLM, and it straddles the divide. It's free to use, but the source code and the training methodologies are not open to the community. And a side-by-side comparison, open source options are notably cheaper, of course. They are free. Commercial alternatives are maintained by their respective companies, ensuring stability and support. Open source models, on the other hand, depend on community input that may drive incredibly rapid innovation, but potentially lack coordinated support. Open source models will offer more flexibility to customize and experiment. So the choice between commercial and open LLMs really depends on specific needs such as budget, required level of support, and required level of customization. The reality is that generative AI is much more than asking a computer to write an article for you. It will impact almost every industry, every business process, all the way up to changing the way that we think about work as human beings. So, the second takeaway is that generative AI is much more than ChatGPT, which represents only a tiny percent of generative AI. Generative AI encompasses any AI system that creates content, whereas ChatGPT is a specific implementation of generative AI tailored for text-based conversations. Applications for Gen AI abound in fields such as marketing, gaming, architecture, media, and so on and so forth, and much more. So here's another poll for you. Which of the following is true regarding large language models? And you can again use the Q&A box to answer this. All right, thanks for your responses. While most of you responded correctly, D is the right answer. They compute weighted sum of the output sequence, right? C could also be a right answer. I won't say that C is a wrong answer. But although it is not necessary that it must be using the transformer model, but yes, most of the large language models are based on the transformer architecture, right? So those who have responded with C, that is also, I would consider it as a right answer. We are now going to talk about generative AI systems. So many systems we did talk about. So far, we have seen some examples from ChatGPT and all, but there might be many different other Gen AI systems which could exist. And they are already there, right? So we are now going to talk about those. So if you just recall that Gen AI technology works by learning from billions of real world data taken from the internet, books, and other sources, right? And the data can be in many different forms. The data could exist, for example, text, images, videos, and so on and so forth. And based on what it learns from this huge amount of data, it creates or rather generates something new in response to a human request. Now, the revolutionary aspect of this is that technology for the first time becomes a collaborative partner contributing ideas and content. It's like moving from having a tool to having a team member, one that doesn't sleep, doesn't get tired, and is brimming with information. Now, generative AI depends a lot on the training data that you feed into it. It analyzes the patterns and structures of the input data to generate your desired content. However, it might not always generate the output that you want. Taking text as input and producing a different form of text as output is the most common form of generative AI. Here's a simple example where we asked ChatGPT to write a brief love note about SaaS software. We use text as input and it produces text in the form of a note as output, right? A very brief note about the SaaS software, love note. And this is what it produced. So here what goes into is text. Here what comes out as an output is also a text. So this is text to text. Let's look at another example. We asked ChatGPT to generate SAS code for computing correlation coefficients between each of the three variables X, Y, and Z, right? It responds that you can use the core procedure with the var statement for specifying the variables. And then it provides SAS code to calculate the correlation coefficient for these three pairs of variables. Therefore, based on input-output framework, there are many types of generative AI systems. This is a text-to-code example. The love note example that we discussed earlier is a text-to-text example. And the associated model type is based on what is going as input and what is coming out as output. A generative model can take text as input and can output text, image, audio or speech, video or 3D animation, code or a computer program or a task, action or decisions, and so on. Thus, text to image, text to audio, text to video, text to task are other types of generative AI systems. Text to text systems take a natural language input and produce a text output. These models are trained to learn the mapping between a pair of text strings, for example, translation from one language to the other language. And this generic structure, which is also exploited by large language models, enable us to model and solve a variety of tasks or variety of problems with a shared approach. Here are more examples. Text classification, also known as text tagging or text categorization, is the process of categorizing text into organized groups. Text summarization is a way to automatically condense and simplify text into a shorter, more digestible form. Text extraction, also known as keyword extraction, automatically scans text and extracts relevant or basic words and phrases from unstructured data such as news articles, surveys, customer support complaints, and so on. Text clustering is used to automatically group textual documents into clusters based on their content similarity. Content editing can significantly improve the quality of content, increase the efficiency of content creation process, and help you save time and resources, of course. Information retrieval is used for organizing, storing, and even retrieving varieties of information from different document repositories, particularly the textual information. These are some more examples. Text to image example. Now, text to image synthesis is a task in computer vision and natural language processing in which the goal is to generate an image that corresponds to a given textual description. This involves converting the text input into a meaningful representation, such as feature vector, and then using this representation to generate an image that matches the description. Generating photorealistic images from text has tremendous applications, including photo editing, computer added design, graphic designing, and more. You can customize your images with different styles, moods, colors, and designs inspired by famous artists with detailed text prompts. Text to image models are trained on a large set of images and each captioned with some short text description. Delhi is an example of text to image generative AI application. Similarly, you might be having text to video. Now, text to video models aim to generate a video representation from text input. The input text can be anything from a single sentence to a full script. And the output is a video that corresponds to the input text. Similarly, text to 3D models generate three-dimensional objects that correspond to a user's text description. For example, this can be used in gaming to the 3D worlds and so on. Text to task system are trained to perform a defined task or actions or any action based on a text input. And this task can be wide range of actions such as answering a question, performing a search, making a prediction, or taking some sort of action. For example, a text to task model could be trained to navigate a web UI or make changes to a document through the GUI. Software agents, virtual assistants, and chatbots are common examples of this type. Similarly, in addition to text, image, audio, and video can be used as inputs too, representing other types of generative AI systems. A generative image model takes an image as input, and the output can be text or another image, audio, or video. A simple image to text example is visual question answering that involves answering questions about an image. Converting an image of text into the actual text is another example. Image completion is an illustration of image to image that uses AI to complete the image that is missing significant amounts of visual information. Transforming an image of text into audio files with the help of optical character recognition, what we call it as an OCR technology, is an image to audio type generative AI. Image animation is another example of image to video in which a continuous display of a sequence of frames is obtained from a given image. And each frame represents the result displayed with a different amplitude. The frames follow each other rapidly, giving the feeling of motion, giving a feeling of that it's a kind of a video. A generative video model takes a video as input and output can be text, image, or audio or GIF file. Transcribing video files into text in different languages is an example of video to text. When you extract frames from your video files and save them as images, or when you make an image sequence from video or capture a photo from video, you are using video to image. Generative AI can extract audio also from video or convert video files such as MP4 to audio files such as MP3. A generative audio model takes audio or speech as input, and output can be text, image, video, or animation. For example, converting speech to text transcript is a simple example of an audio to text system. Audio to image models include creating a waveform image from an audio file or generating an image from music based on its lyrics and sound. You can also convert your audio into a video format by choosing any background that you would like. And you can repurpose your audio files into subtitles or captions added into a video. You can also create expressive facial animation from just an audio source using generative AI. Or you can deliver your message in a playful and engaging way through animated voices. Right? So there are multiple types of input output Gen AI systems exist. Here's a quick question for you. Using an AI tool to translate an article from Spanish to English is an example of which of the following? And can you please use the Q&A box to answer this? What kind of example, input output system example is this? You are translating from one language to the other. What kind of example is this? While most of you responded it correctly, it's an example of text to text generation. You are inputting a text in Spanish and it is going to output a text in English. Right? So text to text generation, this is the correct answer for this. Absolutely. Now let's look at some of the generative AI technology examples. What are the common Gen AI technologies examples. Now, although there is no universally agreed upon definition of generative AI in the industry, synthetic data generation, digital twins, and large language models are all components of generative AI, though in different domains and applications, right? Synthetic data generation includes on-demand self-service or automated data generated by algorithms or rules versus gathered in the real world to meet conditions which are lacking in the real data. Digital twin is a digital animate dynamic ecosystem consisting of an interconnected network of software, generative and non-generative models, and data that includes historical, real-time, and synthetic data that both mirrors and synchronizes with a physical system. Large language models are natural language processing based neural networks with millions or billions of parameters trained on a massive corpus of real world data that track and learn relationships in data to respond to prompts. So these are few common examples of generative AI technologies, and let's talk each one of them a little bit. When it comes to the synthetic data generation, now first of all, why there is a need of synthetic data generation. Data are crucial for the development of AI applications. We all know that. However, real data are expensive to collect and properly annotate, especially when they are in the large scale. Real data can also be messy, requiring time to clean or extract useful features, or it could be both. At times you have enough data, but that data might not be sufficiently relevant to the problem at hand. You also encounter the problem of imbalanced data where the event of interest is often rare, for example, default, which makes it even harder to train good models. The rapid availability of data poses a challenge due to strict privacy regulations by requiring organizations to ensure compliance with laws and governing data collection, storage, and usage, leading to increased complexity in data management, heightened data security risks, limitations on data analytics, and restrictions on cross-border data transfers. So what is the way out then? Whereas original data are collected through interactions with individuals or operational systems of the business, synthetic data are generated by an AI algorithm that generates completely new and artificial data points. Synthetic data reproduce the same statistical properties, probability, and characteristics of the real world data set from which they are trained. It is new to apply AI in the data synthesis process to model the generated synthetic data in an economic way. Synthetic data are also effective in meeting conditions which are lacking in the real data. It is essentially considered to be a privacy preserving technique, and many regulated industries are interested in using the synthetic data. What about the digital twin? Now, first of all, why there is a need of digital twin? Businesses are facing rapidly changing challenges, including geopolitical tensions, technological modifications, say shifts in the global markets, and the impact of climate change. Also, businesses cannot proactively analyze their data to identify problems within the system until IoT leaps forward. It is often very difficult or even impossible to get a real-time, in-depth view of a large physical system, for example, a factory. The non-availability of a large amount of real-time data and hesitation in using advanced analytics prevents businesses from making better and faster decisions. So for the rescue comes the digital twins. A digital twin is a virtual replica or a digital representation of a physical object, system, or process that can be used to simulate its behavior to better understand how it works in real life. A digital twin generally consists of an interconnected network of software, cloud connected sensors to upload operational data, and generative and non generative models also. Digital twins are linked to historical, synthetic, and real time data from the environment, which means that the twin updates dynamically, mirroring the real world. So it's always fresh and hydrated because the data keep coming over here continuously. Building digital twins requires a variety of analytical tools ranging from simulation, Internet of Things, statistical modeling, visual analytics, to computer vision, and so on. AI, ML, optimization, and many more. Digital twins simulate what if scenarios and stress test systems in the digital world to prescribe actions that optimize the physical world to improve the lives of individuals, populations, cities. It could be organizations, environment, system, products, or it could be anything for that matter, right? We can have a digital twin of a factory. We can have a digital twin of a facility. We can have a digital twin of a persona. Suppose you're a doctor, or for that matter, anything, or for the entire city, right? Just search for the virtual Singapore virtual digital twin, right? The digital twin has been created for the entire city of the Singapore, for example, right? So there are many of uh, for that matter. And the third, example is the large language model. Now, why there is a need of LLMs? Whatever the application so far we have discussed about the LLM, for example, text categorization, sentiment analysis, and this and that. All these examples existed even before the advent of the transformer or the LLMs models. We have been doing these kind of applications or natural language processing earlier as well. But why there is a need of large language model over the traditional text analytics algorithms like the RNNs for that matter? Now, conventional NLP models, for example, RNNs, have not greatly been shown to be a reliable way to improve performance on a range of NLP tasks. You cannot scale up such models beyond a point. You need enormous training examples on tasks like sentiment analysis and machine translation. If you have little or no training examples, you will not have any luck. Moreover, you will need separate models and not even one for different NLP tasks, including question answering, document summarization, text generation, sentence completion, translation, and more. For each of these tasks, you need a different NLP traditional model. But when it comes to large language model, just one model is going to do all these tasks. The conventional NLP models also struggle with certain multi-step reasoning tasks such as math word problems and common sense reasoning. One after the other, the sequential things cannot be asked to the traditional NLP, but you can ask the related or the subsequent things or the connected things to the large language models. So what is a large language model? A large language model is a type of natural language processing AI model that is designed to process and generate natural language tasks. These models are typically trained on massive amounts of text data using techniques like deep learning and neural networks with millions or billions of parameters to identify complex relationships in the language. Behind the scenes, it is a large transformer model that does all the magic, which is designed to process and generate data in sequence, like text. A transformer is based on the idea of attention, whereby certain neurons are more strongly connected or pay more attention to other neurons in a sequence. A large language model predicts which word should follow the previous word. One reason these LLMs remain so remarkable is that a single model can be used for many NLP tasks. LLMs can be used in scenarios where little or no domain training data are available, and they usually work satisfactorily, generating something based on some few prompts. But prompt should be efficient and effective, definitely. And there comes the prompt engineering. We have already talked about these things a little bit. So having said all these things, if you talk about the generative AI, generative AI is just a new type of AI. I would say there is this Gen AI is a kind of bit overhyped thing nowadays. It is just another type of AI. In summary, while synthetic data generation focuses on creating data for machine learning tasks, digital twin focus on replicating physical systems, and large language models focused on generating human-like text, they are all part of the broader field of generative AI, which involves creating AI systems capable of generating content, data, or simulations autonomously. Generative AI is not a new type of AI or machine learning at all. The ingredients of generative AI are things like deep learning and reinforcement learning and sampling, for example. And by no means is this an exhaustive list, of course. SAS has a long history in these ingredients of generative AI. Of course, transformers are new to everyone. 2018 is when transformers, one of the ingredients of large language models, come onto the scene. Otherwise, all other things being existed, and SAS is having a proven history in all these fields. And now transformers are actually new to everyone, including SAS for that matter. Right? So these are some of the common Gen AI technology examples we have discussed. Here's again a quiz for you. All right, friends, thanks for your responses. And the correct answer is C, digital twin. A virtual replica or a digital representation of a physical object or a system is called as a digital twin. All right. Some of you have also responded about the simulation clone. While it is sounding very much similar to the digital twin, what is the difference between, because simulation has been existed over and over the decades, right? Simulation is not at all a new concept. Of course, digital twin uses simulation as one of the techniques, but how digital twin is different than simulation? In simulation, the data is not keep coming, and the data is, not, I would say, dynamic. Simulation is having a fixed data, a static data, whereas digital twin, the data is keep coming, and the digital twin keep itself hydrated, and then accordingly changes the thing. So that's how simulation is different than digital twin. That's why D is a wrong answer, simulation clone. If you really want to know more about the digital twin and the difference between simulation and how digital twin is being used, or how generative AI is contributing to the digital twin, or vice versa, there is a blog I had written. You can find that blog in the SAS communities about the digital twin and generative AI, and then you will get a more clarity onto this. All right. All right, friends. So here we move on to the next section of this webinar, and we are now going to talk about SAS, and then I'll also would like to discuss how SAS is seeing generative AI and how SAS is using generative AI or offering Gen AI things. Before that, let us talk about the SAS via advantage.
Data is everything. And now, everything is data. Taps, steps, beats, transactions, debits, credits, shipments, returns. Everything is data. And every day there's more of everything, which means more data, more information, more things to process, more things to analyze. And speed to answers matters more than ever.
So speed to answer matters a lot, right? To answer the questions. And SaaS Via is the latest enhancement of SaaS, which is cloud ready analytics and data management platform. It allows scalable web based access for your data processing needs. SaaS Via provides flexible integration across the AI and analytics lifecycle in many capabilities. Data engineers can leverage upon data standards as they author data tasks in SaaS Via, or integrate powerful capabilities in Apache Airflow with the SaaS Apache Airflow provider, for example. Data scientists can work on their terms in their language and environment of choice and integrate with SaaS Via from their IDE, or leverage SaaS Studio and Model Studio and build models that incorporate the best of SaaS and open source packages in a scalable and manageable way. Business analysts can leverage expanded workflows benefiting from conflict-free open source package deployment in SaaS Via. And through open standards and open container initiative, Via shares your work through, you know, a number of runtime environments wherever containers can be deployed. Cloud, on-premise, in-stream, in database, these are all being possible, right? Having said this, a little more onto SaaS Via. SaaS Via delivers the most optimized performant AI and analytics, which runs faster and lowers your operating cost. At the same time, it provides the assurances needed so you can rest assured that you are driving decisions based on outputs you can trust. Another important thing is it provides end-to-end analytics. So it covers all the pieces of the analytics lifecycle. It is cloud agnostic, you know, the private cloud as well as the open cloud, you can just deploy this. It is open source integrated in the sense that, you know, gone are those days when you say that, okay, if you would like to run SaaS or execute SaaS, you need to learn SaaS. If you have been an R programmer or a Python programmer or say Java programmer or a Lua programmer, or you would like to use some APIs as well, you know, we would say that, okay, you keep doing programming in that your own language or you're comfortable with, and then that is going to be integratable in SaaS Via. You can execute SaaS using Python, for example. You can execute SaaS using R, for example. So you know, you can keep programming. No need of learning SaaS. You can just keep programming in your own language, and then you can execute SaaS. At the same time, you can also some of the open source models within SaaS. For example, you can, if you have been using an R model or a Python model, and you feel that no, I still want to use the same one along with some other SaaS models, you can do that. So it is compatible, you know, in both the sense. You can learn SaaS from open source. You can learn, you can train, or you can run open source within SaaS, both ways. It is data science skill agnostic in that sense, and it is a cost performant leader for that matter. So it can connect all aspects of the analytics, AI and analytics lifecycle, help you turn your critical questions into trusted decisions. So that's why we say it is end to end, right? When it comes to speed, the study proved that Via is on an average 30 times faster than all alternative AI ML solutions across all different data sets and testing scenarios. And compared to the commercial data AI platform, the speed difference is even more dramatic. Vaya is on average 49 times faster. And get this, for complex models, Vaya is up to 326 times faster. Another important thing is when it comes to SaaS Vaya interfaces, it's not that you can just run SaaS only using a programmatic using coding only. There are multiple coding interfaces. There are multiple point and click, drag and drop interfaces. So there are visual interfaces. There are coding interfaces. So you can either code, if you're not very much comfortable with coding, you can even use a point and click visual interface approach. And it is not one, there are many, right? There are multiple point and click interfaces available. There are multiple coding interfaces available. For example, you can code it in SAS, you can code it in Python, you can code it in Lua, Java, and so on. You can code it using the Jupyter notebook. You can code it in the SAS Studio programming interface, and so on and so forth. Similarly, when it comes to the point and click interfaces, you can use it for the uh, visualizations. There is a different tool. If you would like to add some sort of machine learning capabilities in the same tool, it is available. You have a full blown machine learning point and click interface available. You have SAS Studio, you have Model Studio, you have visual analytics, you have visual statistics. There are many, many interfaces available, multiple, depending upon the need of different level of users. For the data scientist, there is a separate one. For the beginners, there is a separate one. For the visualizations, there is a different one, and so on. And on top of all these things, the most important and interesting part is you can use any interface. Suppose you may want to submit the CAS actions. CAS action is generally being used for the programming one, those who would like to generate or have their own AI systems created. We have the procedures available, which are the wrappers on these CAS actions. Then we have the GUI interfaces, like the point and click, say visual analytics, visual statistics, visual machine learning, and there are many more. They all point to the SaaS Cloud Analytics Service. And then whichever way you are running it, they are all going to give you the same results, right? So you will be getting the consistent results irrespective of the fact that which interface or which approach, whether programmatic or point and click you are using, you will be getting the same consistent results. Behind the scenes, only CAS actions are running. So remember that the underlying engine to Vaya is CAS, which stands for Cloud Analytic Services. And it is important to understand that SaaS Vaya has many interfaces to develop models. Whether you are a data scientist writing Python code or an experienced SaaS programmer writing CAS-enabled procedures, or you are using a point and click interface of say SAS visual statistics, right? The same CAS actions will be applied behind the scenes. And this means that we will get the same results regardless of how we created the model.
80% of analytic models never make it into production. Let's change that. Meet SAS Vaya, the faster, more productive AI and analytics platform that works across your entire company. Robust data prep, powerful advanced analytics, and streamlined model deployment. It's never been easier to turn 1 billion points of data into a point of view. And it's fast. Data engineers will help you access, manage, and govern your data so you know it's accurate, high quality, and ready for analysis. Data scientists build best-in-class AI models your way. Code in any language you'd like, or use drag-and-drop tools. Or sit back and let Vaya do the work for you. Business analysts, go beyond basic BI. Tell your data story to any audience. With Vaya's dynamic visualizations and automated insights, you'll uncover hidden value when it matters most. Machine learning engineers. Test, deploy, and manage all of your models, no matter the coding language. Vaya works with you to streamline the entire analytics lifecycle. Take faster, more productive AI and analytics from SAS for a spin and put your models to work.
So if you are a SaaS Vaya end user, here is how it can help you. It can provide data and AI access for everyone, help ensure that everyone can make faster and better decisions. You can move quickly from start to finish without the hurdles. Vaya includes end-to-end capabilities that unify disparate technologies, people, and processes. More easily embed open source models you can here, and the ability to add open source models into your workflow expands opportunities for collaboration. You can make transparent and explainable decisions. Being able to show your work builds trust, and you can use proven AI that delivers result. Vaya helps you discover new opportunities, of course. Here's again a quiz for you. All right, thanks for your responses. And the correct answer is true. SaaS Vaya is a cloud-ready analytics and data management platform that facilitates parallel task execution, distributed computing environment. And this is true. And all of you have responded it correctly. Great, thank you so much for your responses. Now I would like to focus a bit on what is the SaaS's approach on generative AI. All right. And this is really important, that how SaaS is going to use Gen AI, or how SaaS is going to offer Gen AI capabilities in the product, and how we as a company is going to see this, right? As I said earlier, Gen AI is a feature, and there is a lot of, I would say Gen AI is overhyped kind of terminology which is there in the industry today. Everyone is talking about Gen AI, Gen AI, Gen AI, as if Gen AI is going to solve every problem, and the answer and the answer to every problem is Gen AI, which is not the fact. Correct. So let's see how SaaS look at this, and what is the SaaS's approach on Gen AI. Now at SaaS, we consider generative AI as the cornerstone of our market strategy, of course, right? As one of the AI and analytics companies with the longest experience in the field, SaaS is equipped to be the trusted partner to help organizations to confidently succeed in the generative AI journey across different industries, regulatory scenarios, and application areas. Our goal is to enable organizations to securely adopt generative AI for accelerated business productivity, results they can trust, and faster innovation. Right? So our commitment to Gen AI is definitely there, no doubt about it. Now, When it comes to generative AI in action with SaaS, we see that, or we can say that there are three pillars we foresee here, right? SaaS via explain, govern, orchestrate the LLMs via copilots and synthetic data generation. Let's delve into each one of them one by one. Let's first talk about the SaaS via platform, how this platform can be used to explain, govern, and orchestrate the large language models. All right, I'm talking about the first pillar. Now, as organizations experiment with generative AI, SaaS recognizes that real business value comes from the ability to integrate it as part of their existing market strategy and intellectual property with ensuring applications, while you can ensure the applications can be trusted, applications of Gen AI specifically can be trusted. SaaS via is a data and AI platform that enables organizations to securely orchestrate their LLMs usage. Integration with via decisioning workflows, machine learning algorithms, and data protection capabilities not only drives innovation, but also provides trust and transparency, right? So what all the areas where this can be applied, wherein the LLMs can be used in tandem with, integrated with SaaS via platform using different APIs, and we can then explain, govern, and orchestrate the LLMs. It could be, it could be used for prompt management with SaaS via. You can create and maintain a catalog for prompts for large language models, or it can be used for data pre-filtering with SaaS via, wherein this can be used to improve the LLM's explainability while reducing cost and hallucinations. So it is more about, this can be used for data pre-processing, the textual data what you can pre-process so that the hallucinations can be minimized. So data pre-filtering also can be used with SaaS via as a Gen AI application. LLM governance with SaaS via. You can enhance the governance on large language model. You can establish the mechanism for receiving and addressing feedback from the users, regulators, if at all they exist, and other stakeholders about the large language models compliance. We can also use it as an enabler for conversational AI with SaaS via. And this is going to accelerate the business and industry processes with LLMs and analytics together. You can combine the complex math with Gen AI for a conversational experience with data and AI, right? You can just have a conversational AI. Okay, just change the suppose in an optimization problem, you can ask that, okay, change the right hand side constants, right? And then you can retrain the model and then give me the results, right? So we can enable the conversational AI also with SaaS via. In addition to this, we can also combine the Gen AI and decisioning with SaaS via. We can transform the large language models into a business decision. We can integrate Gen AI models with decisioning workflows with the existing business processes, and AI ML applications can be combined with them so that the better business decisions can be made. Gen AI process automation, we can also use it for that. We can improve oversight and accountability on large language models, wherein we can automate this entire Gen AI process. If something happens A, then do this, or kind of a workflow, So we can leverage the built-in workflows to validate the LLM lifecycle from a regulatory model perspective. Let's see a real world example. We just talked about at a very, very high level all each of these things. Let's see a real world example how this can be implemented. Now, imagine that a bank has complaints from different channels like web page, email, uh, text, phone calls, and they were already using existing solutions to do some sort of management of the complaints, but they wanted some additional capabilities, right? Obviously, they would like to provide resolution for the customers about these complaints being raised by the customers. Specifically, I would say, they wanted to be able to summarize conversations that had taken place over several contact episodes so that a new operator could quickly catch up with and understand the situation without the customer having to tell their whole story again. They wanted to automatically generate a reply to the customer, and they wanted the complaints handler to review the reply before sending it to ensure that it was appropriate. All these things we would like to do in this business scenario, and they wanted to use LLMs for this matter, for this particular task. Now, this is typically the 90% of the conversation today with organizations. They already have some sort of system in place that do some basic or complex analytics. There might be some degree of automation to that, attached to that, and they are wondering, how do I use LLMs to make all these things better and faster, right? So they do have some analytical capabilities, they do have some existing systems and all, but they still want to use the LLMs so that they can make the decisions faster and better, right? We have all come to the realization that LLMs alone do not solve business tasks. Generative AI is nothing more than a feature that can augment businesses' existing processes and make them faster, right? A large language model or a Gen AI tool alone cannot solve any business problem. But to get there, you need systems and technology that integrates LLMs with your existing processes, and you need developers and engineers to maintain and govern them. Definitely. SaaS Via is helping with exactly doing just this. Here is how we applied it to this use case. Developers used SaaS Via to build a flow that for each complaint would send the full text of the complaint, and any previous interactions is then sent to the LLM, which provides a summary. All right. That summary is then sent to SaaS Via, which uses natural language processing techniques to explain how the summary was generated, takes the customer information from the enterprise database, such as customer churn probability, customer credit score, customer value or customer lifetime value, and then uses a decisioning system to recommend a next best action. All this information is then passed back to the LLM to generate a reply to the customer. All right. The operator reviews that reply and can then send it to the customer if considered appropriate. And this is more to avoid the hallucinations, because we know that hallucinations are indispensable part of any Gen AI system. So a human check is required many a times, most of the times. Or the entire process can be automated based on the level of human in the loop necessary. Now, the important thing to notice here is that all the different tasks involved in this use case, only two were handled by LLM: summarizing the complaints and generating a reply. Only these two. The other important things like recommending the next best action, incorporating your customer information, orchestrating the full decision making process are handled by the platform, the SaaS via. So this is what we would like to convey, and we firmly believe in this entire concept that a large language model or only a Gen AI system alone cannot solve the entire business problem, right? So this is what we meant that VIA allows developers to explain, govern, and orchestrate LLMs, integrating them with decisioning systems. Now, customer complaints in banking is just one example, one of many different types of examples or areas where this is leveraged. Think of credit lending, other scenarios where you need to analyze documents and take an action on them. LLMs only won't do it, right? So this is what we meant. SaaS via, you can explain, govern, and orchestrate the LLMs over here. Now, what are the benefits? What are the benefits of using this or this methodology? The benefits that we saw from integrating generative AI to the existing business processes of the bank of this particular use case were really great. We were able to decrease average complaints handling time by 20 to 40% and increase the volume of complaints handled by up to 20%. The average response time decreased by 30 to 40%, and the complaint resolution time by 20 to 25%. The cost of handling complaints also decreased by 8 to 15%. So these are the obvious benefits when you integrate or when you integrate the Gen AI system with your existing systems. You know, uh, you will be definitely getting the benefits in terms of automation, in terms of faster decisioning and things like that, and efficient working, of course. Here's a demo I would like to show you for orchestrating and governing LLM usage with SaaS via another demo. This was the example. Now here's a demo I would like to show you.
SaaS enables you to process multiple documents automatically using steps configured to prompt an LLM to execute various tasks for each document. In this example, we've imported multiple SARs, or suspicious activity reports, and have a series of flows to discover important entities and identify relationships, answer questions such as what locations are mentioned, identify information gaps and suggest tasks to fill those gaps, and summarize the report overall. The free-form query for the prompt allows you to give instructions to impose guidelines and follow standards. The flexible flow definition enables chaining queries to LLMs and utilizing the responses as necessary for your specific business problem. Here we identify all anomalies in each report and ask the LLM to act as an intelligence officer to determine probable crime trends from the reports. Generative large language models can be called from SAS Via using SAS's prompting interface. Here we have a number of tasks for querying LLMs, each one serving a particular purpose. In this example, we are calling GPT-4 to answer a table of questions provided by the user. Prompt engineering is built into the prompt catalog steps so that only relevant responses are given. The user is able to supply a table of questions to ask their own question, or add their own prompt for a more customized response. The responses for each question are given in a table which the user can export. This solution enables asking and answering both questions from either a commercial or locally hosted generative AI model in an efficient and easy-to-use way. For more effective prompt management and usage, a workflow can be employed to allow scoring the effectiveness of different prompts from the prompt catalog in achieving appropriate LLM responses, giving the user the ability to select the recommended prompt, which might evolve over time. As with AI in general, greater value from generative AI is often achieved by incorporating it into decision flows. SAS enables you to add steps that execute prompts to LLMs so that the responses can be further processed by our core NLP capabilities and included in downstream logic for making automated decisions. In SAS Via, the AI models used by an organization, including LLMs, can be inventoried and governed to ensure appropriate use and regulatory compliance. Here, we have a Llama 2 model fine-tuned to process legal documents. A well-defined lifecycle must be followed, including validation that might include checks such as adherence to the EU AI Act, other government standards, model tiering from a risk perspective, and a review of potential bias before the model is officially approved to be deployed and used in production. SAS enables
Right. So this was one of the example, one of the demos I wanted to show you in explain, govern, and orchestrate the LLM. So it's more about integrating the Gen AI systems with the existing SaaS platform. The second pillar over here, when it comes to generative AI in action with SaaS, is the VIA copilots, right? And this is more to accelerate AI lifecycle industry business tasks. So SaaS is currently developing copilots that democratize the tasks across the entire analytics lifecycle. These copilots allow users to interact with the software in a more conversational way and lead to increased development speed within VIA. The specific examples might include auto-generated code, dashboards, and data quality checks. Leveraging these copilots accelerates the end-to-end analytics lifecycle, resulting in faster innovation and greater return on investment. Right? These are some of the, I'm not showing the demos for each one of them, although we do have those demos available. If you can just search the www.sas.com, go to Gen AI, and then you would be able to see some of these demos. So there was a demo on the law enforcement, for example, marketing intelligence, and so on and so forth. Right? I'm not showing you those things over here. Just one of the example I'm going to show you. So what is the idea here is that we at SAS is building intelligent assistants that have industry specific knowledge related to enterprise use cases and or the business tasks. This is linked to our goal to accelerate productivity and innovation for our customers. And intelligent assistants empower individuals or users to perform their tasks more efficiently and effectively. Let's look at this example. This is a low code, no code code generation example. And this is still not out, but we are anticipating that this is going to be offered anytime soon this year.
Coming soon to SaaS Via, programmers will have a copilot to assist them with coding. Here, we are asking a large language model to explain a huge amount of complex AI code that performs a specialized form of time series clustering. The copilot is able to accurately understand the code and gives a good summary of what it's doing. Programmers will also have the ability to add comments to code. Here is uncommented code that performs a special form of parallel processing. The copilot analyzes the code, understands what it does, and adds appropriate comments where necessary. Finally, programmers will be able to generate their own code. They write a comment describing what they want to do, and the copilot generates SAS code for them using the context of the code before it and the content of the comment.
Right. So this was more about a kind of a SaaS co-pilot, which will be coming soon. So if you don't know how to write the SaaS program, you can just ask the co-pilot that you have to describe that, okay, give me the code. I would like to calculate the correlation between the three variables, say X, Y, Z, and write a code for that. And then it is going to write the code for that. Or if you have got some piece of code available to you, and you just want to understand what exactly this is all about, then you can use the explain feature of that, and then that entire piece of code is going to be explained to you. You would like to add some sort of comments to that. So a lot of things you can do. And this is going to be a very interesting capability. You can see this year coming soon. All right.
Coming soon to SaaS Via.
And here we go to the third pillar of generative AI in action with SaaS, what we call it as the synthetic data generation. And this is more to mitigate data quality and scarcity. Now, synthetic data can be used for a variety of purposes. We all know that, such as testing algorithms, training machine learning models, and ensuring data privacy by generating data that doesn't contain sensitive information. It removes the privacy concerns, data quality issues, and access limitations that researchers, developers, and data scientists generally encounter when working with the real world data. Right? So there is no good AI without good data, and we all know that. And this is more critical with the advent of the machine learning algorithms or the deep learning algorithms, because you need to have more and more data in order to process that kind of information, right? Or in order to get the answers of those kind of questions, the very complex questions. So you cannot perform a good AI without a good data. And sometimes the real world data, it is not good enough, and it has sensitive information. Some privacy concerns could be there, and it is just not enough. You do not have enough data available or enough relevant data available, for example. So simply put, I can say, you can get more work done. You can produce a large volume of output that subsequently drives organizational key performance indicators and overall businesses with the synthetic data generated. Synthetic data generation is currently available via coding and will soon be available as a low code, no code option also. So here's a preview for you. The preview is about the data maker, right? This is the SaaS data maker. Currently, SaaS offers the synthetic data generation capability using programming interface. You can program, you can write a code, and synthetic data can be generated. Soon you will be having this low code, no code, what we call it as the SaaS data maker, a visual interface, which can generate high quality synthetic data for you. which you can validate the quality of the generated data, and you can export the data for further analysis. So here you see the SAS data maker. You know, this is a preview of the SAS data maker. You have to select here the data. So first of all, you have to give a table to that, which is going to be an input table, and it is going to maintain, it is going to preserve the probability distributions or the characteristics of the data what you will be supplying. Here you see that, you know, we are seeing that select the data. So you have to select the input table. You can go and select the input table, right? Number of records to be generated. We say that we need to generate 10,000 records for that matter, using that kind of data which is there in the input. And then here the data is generated for you. How many number of columns, number of rows, and so on. You can check the quality score representing here. So higher the score is, better the quality of the data. You can see the correlation matrix with the of the original data as well as the generated data, and you can see that there is a very low correlation exists when it comes to the anomalies out here. You can look at the individual distributions of the variables here, right? The distribution with the blue and yellow, it's going to be the original versus what has been synthetically generated. And then you can save the synthetically generated data as a table over there, and then you can use it for the further analysis, right? So this was a preview of the SAS data maker, which is again going to be expected to be coming this year only. All right. Any questions you have for me? If you have any questions for me, please do let me know. Okay, I can see there are quite a few questions here, and let me take these questions. Okay, I have a question from Ishan. Ishan is saying that while I believe the answer would be true, that SAS Via has a distributed computing environment, I have noticed that SAS Via didn't run large tasks in parallel when I used it for ML. Now, Ishan, uh, you said that it can't run the things parallel. See, the beauty of SAS Via is you can add the resources and you can remove the resources. If you feel that you are having a large amount of data, and if you feel, if you believe that, some sort of computing power is required, you can just scale it up by adding more computing power, by adding more resources. And when you believe that, not that much resources you want, you can scale it down. So at any point in time, you can scale it up, you can scale it down depending upon your need. So it is not true that it cannot run the large task in parallel. It can run the large task in parallel, but of course, it requires more computing resources to be added, right? And it's not that when you add the more resources, those resources are going to be added forever. You can scale them down as well, depending upon the need. Can we build digital twin on SAS Via? Grace, you have a question. Yes, we can. In fact, we did have there is a demo video available on YouTube, which talks about that how SAS Via is being used for building a digital twin. It was a component replacement for CPU computer, computer CPU, and it can be used. So it has already been implemented. When you search the digital twin using SAS, you will get a lot of information out there. Can we request a copy of the presentation? That is not going to be possible because this is an IP material owned by SAS, so that won't be possible. Is there inbuilt connections to LLMs from SAS via interface? See, Nishikant, you are having a question here. Is there any inbuilt connections connectors to LLMs. So there are several APIs that are supposed to be used here, and there are a multitude of number of APIs which can be used in order to connect to SaaS Via. Another question I have here is, does the Via Copilot can provide insights? Via Copilot can provide insights, as in, yes, it can provide insights in terms of what this code is all about. It can explain the code. It can explain each keyword over there, and so on. What SaaS tool for school? Standard. I am from CBSE school. You can use, there is a free tool called as Soda, SaaS on demand for academics, and you can use that for your basic things to be done on SaaS. So Dinkar, I answered your question as well. The generated data normalized in L2 form, you have a choice, Nishikant, what all regularizations you would like to apply. Another question I do have, where can we learn generative AI using SaaS? I'm going to give you a link or the heads up for the free training on generative AI using SaaS, Neelam, at the end. Uses of SaaS via for marketing intelligence. Yes, there are a lot of use cases. You go to www.saas.com, go to industry, and within industry, you will find the marketing and all other fields out there. And there are a lot of use cases being discussed out there. Just want to know about placements for that also, that I'm not sure about that. SaaS via offers any voice cloning feature in future. Voice cloning feature. See, David, this is what we are trying to say. We are very clear in our strategy. We have been doing analytics over and over the years. From last more than 4 decades, we are the leaders in the field of AI, ML analytics, basically. And we would be focusing, as of now, this is what our strategy is. We would be focusing on doing what is our core responsibility is, or what we are good at, which is analytics. Now, voice cloning, there are many applications available. What you have to do is you have to simply see that you have to find out the relevant API, and then you would like to try to connect it to SaaS via, and then you can use it. We do not have any mandate right now that we will be getting into the as a Gen AI provider. Not at all. We will be using, or we will be consuming the Gen AI things which are available, and we would like to improvise those things, and we would like to package it as a kind of an AI offering per se. That's what the idea is. So voice cloning feature can be used using and can be integrated with SaaS via using a relevant API, right? Thank you so much for being so interactive and asking so many questions. I would love to take up your questions more. So keep writing in the Q&A part, and we will be I'll be trying to answer your questions. All right. Okay, here we come to the last section of this webinar. And this is a very, very important section, I would say, because everyone thinks about when it comes to AI or Gen AI, everyone believes that, oh, this is just be something very rosy, very fascinating. It is fascinating. I won't say that it is not fascinating. Feel it is, but you should be aware about the risks also. It's not only rewarding, there is a risk involved in this. So that's a challenge, basically. That's an AI challenge. How you should balance the risk and the reward both, right? And it is very important for me to sensitize you at least on this particular thing. So let's talk about the AI challenge and how we can balance the risk and the reward. And this is going to be the last section, as I said. So obviously, we have been talking about the benefits and, so far. So there is some goodness that comes with AI, no doubt about it. And that's why we continue to use and develop the technology. AI not only makes our lives more convenient by automating manual tasks, but it offers deep, consistent levels of intelligence that can greatly enrich our lives. You can reap benefits of AI in almost all walks of human activity. But in areas like medical sciences, researchers are seeing some promising results from AI technology that includes improved screening of certain life threatening diseases like cancer. Moreover, AI can also help monitor endangered species in the world and so on. So, when it comes to the AI benefits and rewards, we know that it can automate the repetitive learning and discovery. It can perform more deeper analysis. It adds more intelligence to the existing products. And it is going to give you the consistent accuracy because you keep on doing the same thing here and out. Right? So there are benefits, there are rewards, no doubt about it that AI is very fascinating to use and it is giving immense uh, benefits and rewards. But like other innovations, AI also poses some risks and threats in addition to its numerous rewards. If we are not vigilant, negative bias can unknowingly be transmitted to our algorithms. And that bias most likely will be greatly amplified. Humans can make decisions only so fast, but technology accelerates that process immensely. We all want things instantly, on demand, and AI makes that possible. But there is a serious risk when we start making really fast decisions at scale. A human can process a handful of loan applications in one day, but a computer might be able to process thousands of them, which means that if something goes wrong, it could quickly go very, very wrong. The impact of bad decision making gets much bigger and much faster. And that leads to the question, who is going to be accountable? Who to blame for that? Because it is driven by the algorithm, it is driven by AI. So acceleration is actually implying here the risk of making really fast decisions at scale. Amplification, bad decisions get much bigger, and accountability. Who is going to be responsible for if something goes wrong? So these are the obvious risks while using AI in decision making. AI is essentially the story of starting with real questions, right? Here we would like to talk about how AI is associated with the analytics life cycle, or AI challenges that are associated with the analytical life cycle. So AI is essentially the story of starting with real questions. So questions on the left hand side, and then using your data to make decisions based on understandable, actionable insights. And the process takes us through three primary phases of this. So you'll start with a question, and then we would like to make a decision. In between these two, the process takes through us three primary phases: manage data, develop models, and deploy insights. So data, discovery, and deployment. These are the three pieces of the analytics lifecycle. First, manage data. The manage data phase provides an agile approach to data access, preparation, and governance. It enables greater reliability, speed, and collaboration in your efforts to operationalize data and analytic workflows. AI models are trained on historical data and can perpetuate biases that were hiding in the training data. AI technology often uses sensitive data such as private personal information, healthcare data, or business use cases for creating, training, and using models. Unauthorized access to or inappropriate disclosure of these type of data can cause harm to individuals or organizations. In addition to this, AI models are only as good as their data. Garbage in, garbage out is extremely accurate when applied in the AI context. If the data are not good, the AI model will not be good, leading to problems such as bias, discrimination, and inaccurate predictions. Second, in the develop models phase or the discovery phase, data scientists use a combination of techniques to understand the data and build predictive models. They use machine learning, natural language processing, forecasting, optimization, and other techniques to answer real world questions. AI models are opaque and difficult to understand. These are the black boxes. Lack of transparency in AI models makes it difficult for people to understand how decisions are made, the intended scope and outcomes of the AI models too, and whether there are potential biases in outcomes or not. Transparency of the model decision making process fosters trust and understanding. And third, the deployment phase or the deploy insights phase focuses on getting AI models through validation, testing, and deployment as quick as possible while also ensuring quality results. It also focuses on ongoing monitoring, retraining, and governance of models to ensure peak performance and transparent decisions. Right? Manage data, the first piece is basically the data ops piece. Deploy insights is what the model ops piece is. So having said this, the deploy insight piece, it can be difficult to ensure that AI models are deployed to production in a reliable and secure way, governed in a way that is consistent with organizational policies and procedures, and monitored for performance and accuracy. Right? So as a response to all these challenges in this entire analytics life cycle, trustworthy AI is critical because it helps build trust and it promotes transparency, accountability, safety, and security. And this is all going to lead to fair and equitable outcomes. SaaS Via provides capabilities to help you with your trustworthy AI journey throughout the analytics lifecycle. For example, in managed data phase, SaaS Via supports data access, preparation, and governance. Private information is automatically tagged, masked, anonymized, and suppressed. Automated data exploration uncovers completeness, uniqueness, distinct values, semantic types, correlated variables, mismatched values, outliers, and more. GANs, generative adversarial networks, and SMOT, synthetic minority oversampling technique algorithms generate tabular synthetic data as a rescue. Similarly, in the develop model phase, Via builds, optimizes, and validates models. It helps you understand the interpretations of the models using partial dependence. PD plots, individual conditional expectation plots, ICE plots, local interpretable model agnostic explanation line plots, and hypershaft values, kernel shaft, and explain them using natural language generated outputs. And it assesses model fairness and mitigates biases. So there are abilities which exist in SAS via, which it provides you model interpretability, although we know that most of the machine learning algorithms are not interpretable, they are black boxes, but it has means and ways. It provides SAS via provides means and ways so that you can add model interpretability. If you're getting a result, or if you're getting a output or a plot out of a SAS via as a result, it is trying to explain you that what it all explains using the natural language insights capabilities exist over there. So a lot of functionality is available out there. And likewise, in the third phase, in the deploy and insights phase, it secures model ops processes. Models go through validation and testing to the deployment phase by automating, monitoring, and retraining. A centralized searchable repository of all types of models and analytical assets ensures transparency, traceability, and complete visibility into an analytical processes. So we do have tools available. We do have offerings available. For example, SAS Model Manager is the tool which is going to secure this thing, or which is going to offer all these functionalities to that. So we do have different offerings, right from managing the data, developing the models, and then deploying the insights. And there are different pieces of offerings available in SAS via in this entire analytics lifecycle. Right? Now, things to be aware of when using generative AI, and it is very important for us. Although Gen AI is proving to be extremely powerful, there is a risk of this technology being used in a wrong way. And it's very important to you to be sensitized on this. Now, there are many things to consider when it comes to using Gen AI responsibly. Let's point out a few. There are a lot many listed over here: bias and fairness, quality and consistency, ethical usage, generalization, robustness, long-term effects, accessibility, explainability and transparency, resource intensity, controllability, data privacy, and lot many. Let's focus some of them over here. I'm sorry. A computer doesn't just grow a brain and create something brilliant by itself. Instead, what it does, it trained by humans, meaning that it inherits humans' biases, leading to the generation of fake or discriminatory content. So fairness and bias is very important, right? Similarly, the information that it draws from is not always accurate. In fact, sometimes ChatGPT just makes up the stuff for you. OpenAI gives a disclaimer that ChatGPT sometimes writes plausible sounding but incorrect or nonsensical answers, right? So quality and consistency is also very important. You should be aware about this. Training large generative models requires significant resources and energy consumption, raising environmental concerns. So resource intensity is a concern here. The large language models, when they are trained, they just went on for days and months, and they consumes a lot of power. That is also a concern. The need to have regulations in place is critical to blame innovation and with responsible use. Policymakers need to stay informed about the technology's capabilities and risk as well. So there should be some regulations. Yeah, it is surprising. I can see your emojis here. I'm talking about the training a Gen AI system. Suppose training a Chat GPT model. When you ask a question, Just try to understand what I'm trying to say here. When you ask a question, when you write a prompt to say GPT, chat GPT, right? What that prompt is going to do, that prompt is going to go through the pre-trained model, which is already being trained, having billions of parameters into it, and then gives the results, right? But that model has to be trained, right? And when that model was trained, it might have took many months to go. And then there is a need of retraining a model when the model is not performing well. So every model is having its own life, right? And when it again comes to retraining that model, then again it has to train those weights so that the results can be further improvised and things like that. So I'm talking about training that model. I'm not talking about scoring. What you are doing by asking a prompt is actually you are scoring. You are getting the scoring done out of that model. But that model is a pre-trained model, and when it was trained, it took many days and months to go. That is what I was trying to tell you. So the third takeaway for you is that generative AI is not ready to operate without human oversight. Generative AI is based on algorithms that respond to models and data, and it often misses the big picture and most times can't analyze the decision with reasoning behind it. It isn't ready to assume human qualities that emphasize empathy, ethics, and morality. All right. So it's very important, very, very important. So here we see the three key takeaways of generative AI, and let me summarize them. Generative AI transforms the interaction between human intelligence and artificial intelligence. Generative AI is much more than chat GPT, and generative AI is not ready to operate without human oversight. So here we comes to the end of this webinar. If you are having more questions, you can type your questions in the Q&A box. There was one question that from where we can learn, and here are some heads up for you. SAS offers these two free trainings to you, and these are the free e-learning trainings. Generative AI using SAS. The link has been given to this over here, or you can simply go to www. Or simply go to learn.sas.com, and then you can find them up. There is a course on generative AI using SAS. Much of the some of the part of this webinar has already been taken from this Gen AI using SAS, some preliminary modules. So it would be, and this is an e-learning. You can just use your own pace and then you can listen to that. You have to get yourself registered using your SAS profile, and then you can go through this course, generative AI using SAS, right? This course includes some demos also, how the synthetic data is being used, and a lot of conceptual material is there. You can even deep dive a little bit. And this is an ongoing work on this, because as this generative AI field is evolving, we are keep adding the modules to this. So this is a work in progress. Currently it is having, I think if I'm not wrong, it is having around 10 modules into it, and we will be keep adding more modules as and when more offerings will be there, and as this field of generative AI getting matured. So you can go through the Gen AI using SAS. We also offer a responsible innovation and trustworthy AI course. And this is again a self-paced e-learning free course. The link has already been shared with you. And we believe at SAS, especially, we believe that doing AI is a different thing and doing AI responsibly is a different thing. And we believe in responsible and ethical and trustworthy AI. So this is going to touch base on the deeper understanding of the importance of trust and responsibility in AI, and what are the pieces and components out there. So these are the two free trainings related to this field you can go through, and you can obtain a badge after completing these two courses. You will be getting two separate badges for them. I'm not pretty sure whether badges are available right now, because the, both of these courses are work keep going, but you can definitely, once you complete all of them, then this is already being done. All right. All right. Thank you so much from my side for being with me. I hope you have enjoyed the session. You have found the session useful for you. And that's all from my side. If you have any questions, just do let me know. Otherwise, we are done for the webinar.